My name is John Dreher, and my title is Electrical Manager. Questions that we normally ask clients about for electrical design would include things like priorities between cost of systems, ease of use of, say, lighting control systems, specific requirements that might be needed for brightness levels in, say, laboratories or conference rooms, specialty fire alarm requirements. Maybe certain clients might have request extra smoke detectors in coverage in certain areas of the building. So things like that. We try to get into more of the details of what a specific owner would like as opposed to just a general design. The services that Strang provides in its electrical department is quite diverse, actually. We work directly with the architects and the other disciplines, and the specific electrical areas that we work with are lighting and lighting controls, power distribution, electrical services in coordination with the utility, emergency generators and lighting inverters as well. We work with UPS systems, that's uninterruptible power supplies. We also work with and design data systems and specialty systems like nurse call, as well as audiovisual systems. Aspects of electrical engineering that are often overlooked or underutilized are some of the behind-the-scene things. So every client interfaces with the lighting controls, for example, but the things that involve safety and code requirements are usually behind the scenes. And usually with electrical, those types of items are no news or good news. And so, for example, withstand ratings and fault currents are extremely important for safety in electrical system design, but they're rarely discussed or talked about. It's usually just anticipated that the engineer is going to handle them, and we do. Different building types have different demands on the electrical systems and designs, and so in general, a laboratory, for example, compared to an office building, we really do approach those two completely differently because we understand that the construction documents require a different level of detail for those building types because different contractors, they may be more familiar with an office building than a lab. They may need more information on the lab and requirements. Then when we talk with the client about what those requirements are, then we document them to make sure that the contractor understands what is required. And in general, from an electrical power distribution design, an office building, for example, usually only has, I'll say, a single path of electrical power distribution, where a laboratory might have two parallel paths, so that one is a normal power path and another is powered by a generator, so that in the event of a utility outage, that the entire laboratory can remain active and in use while the utility fixes the power outage. So the way that I approach lighting design and lighting controls for buildings is we have a substantial amount of experience in different building types, and so we have a common understanding of what is normally required in that type of a building. But then, as we discussed earlier, we talk with the client about what their needs and requirements are, and then we adjust those, I'll say, general lighting approaches and tailor them to be specific to what an owner would want. So skills and interests that I have outside of work include photography. And one item that I really like from photography is seeing the effect that lighting can have on the desired outcome for my photography. And so I can apply that to my lighting designs at work too. So you can make a huge impact in a lighting layout in a room. And so I do that with photography sometimes, where we look at where's the light coming from? Do we need to have a flash? Do I need to move a few feet over to one side so that either the item is front lit, side lit, or in some cases backlit? It all can make a dramatic difference in how the photograph turns out. Well, I decided to become an electrical engineer simply because I always wanted to be an electrical engineer. When I was young, I would take apart electrical items and rebuild them, and sometimes it would work and sometimes it wouldn't. And I learned from those experiences, and I always enjoyed electrical. I have other interests too, like for example, mechanical and photography, but I think electrical engineering is just something that it's always been interesting to me. And working in the building design system as opposed to the electronics industry has been more interesting to me because I love buildings and I love architecture, so it's great to be a part of that. So the challenges in the electrical field are primarily trying to balance cost with quality, and then also trying to coordinate, I'll say, physical aspects of electrical equipment. It's interesting that a lot of folks look at electrical as being a very technical field, and it is simply because they're not aware of it. I'm sure that they can learn it, but they haven't spent the time to learn it like an electrical engineer has. But a lot of the challenges that we have are physically making sure things fit. Example would be light fixtures too. When you have a ceiling height that's requested by the client to be as high as possible, but the light fixtures are recessed and we have to coordinate with the ducts, the piping, the structure above. So again, it's the light fixture coordination, the challenging part, really becomes the physical coordination. And that's actually where Revit and the 3D modeling actually has played a huge role and has helped us tremendously to coordinate those types of items before the drawings even go out for bid.